Hello everyone, my name is Danett Dellano, and in this case we will be talking about simple harmonic motion equations as well as their derivatives. So when stumbling upon simple harmonic motion, we will be given the position function, which is represented in x in a function of time, which is, we know that a is the amplitude and we're using cosine, omega is the angular velocity, and t of course is time. Now, what we're trying to get at is we're trying to use the position function and find the derived function from the position function. And in general, we know that position, velocity, and acceleration has a relationship in which they are their derivatives from the previous unit, in which velocity is the derivative of position and acceleration is the derivative of velocity. And in some basic concepts and theories, we can see these in their units, in which position is usually described in meters, and velocity usually described in meter per second, and acceleration in meter per second squared. From these units itself, we can understand that they are each derivatives of each other, and we can use this logic in order to find the derived functions. Starting from velocity, as mentioned previously, we are going to be introduced with the position function. Then, using the same logic, we will need to derive this function, which will find us the velocity. So it would be dx over dt, and meaning we would need to derive the x function. And when we do that, we will remain the amplitude and would be angular velocity multiplied by amplitude and then multiplied by negative sine to angular velocity times time. Negative sign, of course, this results in the derivative of the x function. Then once simplified, we get this velocity function, which we can use, which states velocity equals negative angular velocity times amplitude multiplied by sine to angular velocity to time. Now that we have both the position function as well as the velocity function, we can do our same task to find the acceleration function. Using that logic that the derivative of the x function is velocity, we can again use the same method to find the next function, in this case, the acceleration function. So, meaning that when we derive the function of x once more, we will get the derivative of the velocity function, which will give us the acceleration function. So just to make space here, these are the information that we have, and we can use the same method and the same logic in order to find the acceleration function. So the acceleration function will be the derivative of the velocity function. And when we do so, we will find this, in which acceleration equals the negative angular velocity, which we get from the previous equation, times angular velocity multiplied by amplitude, again from the previous, and then multiplied by cosine, which is of course, the derivative of the previous function. When we simplify that, we will get acceleration equals negative angular velocity squared. And to simplify here, we can see that the a times cosine to angular velocity times time is actually the same with the original function that we can see of the position function. So to simplify, we can get the function of acceleration equals negative angular velocity squared times the position function. So to summarize and recap, we have three different physical units here, which is position, velocity, and acceleration. And given from the position function, we get the first given function. And when we derive that, we would get the velocity function and then the acceleration function. That will be all from me, and thank you for watching.